Start recording? Yes. Good afternoon, and there we go. And welcome to Comp 422 and Comp 620. We talk about digital money today, and later on we will discuss the first exam. I've got all sorts of information about that coming up. I'll remind you on Wednesday, 2 days from now, at noon is the deadline for the number-based online quiz. That's where you go out there and you answer questions. F is what in decimal? It's 15. And do 20 of those. You have to do them quickly. Not too quickly. You have 9 seconds to do each one. You have to get 20 questions completed in 180 seconds, 3 minutes. It's not hard if you practice a little bit. If you sit there and just take your time and take over 3 minutes, you'll lose points. Your score is percent right minus number of seconds over 180. You can do it as many times as you like. I will take your best score. So this is an easy 100 if you try. Okay, today, in addition to talking about the exam, we'll also work on blind signatures, in case you haven't had enough with signatures. We'll also consider digital currency options and look at what the US government is doing about digital currency. Okay, a quick review about RSA encryption. As we all know, you can encrypt something by raising the message to the power E mod n, where E and N create the public key of the RSA algorithm. And then that becomes cipher code. You can decipher that by raising C to the D, D being the private part of the key, mod n, and that gets the message back it was. That's for encryption. You can sign things by raising the message to the power D, that is your private key. So if you raise S to the private key, and then becomes signed, that is, anybody can decrypt it if they have the public key, which is publicly available. Nice thing about the RSA algorithm is you've got D and E, public key, the private key, and you can encrypt with either one and decrypt with the other one. If you encrypt something with the public key, then only the person who has the private key can decrypt it. On the other hand, if you encrypt something with the private key, that anybody can decrypt it, but as you decrypt it, you know that it came from the person who has the private key. Typically, you only encrypt a hash of the message, not the whole message. Just a reminder, I think everybody knows this by now, that you take two big primes, you multiply together, you get n, and one less of those two primes multiplied together, find a number, it gives you n and d. You have to be the multiplicative inverse of those numbers. Okay. You can sign something with a blind signature. It allows you somebody to sign something without seeing what the message is. Typically, you look at the message, and you can sign it, which is what you'd want to do if you were going to send a message or something. But a blind signature allows somebody to sign it without looking at the message. This does have several advantages. It's created by Dave Shum, whose name we'll see a little later on. You can equate this to the idea of putting a piece of paper in an envelope with a piece of carbon paper on top of it, and then somebody signs the envelope, pressing down hard, and that will create the signature on the piece of paper that they don't get to see. Later on, you can remove that paper from the envelope and have a signature on it, even though the person who signed it didn't get to see what it was. I realize that most of you have never seen carbon paper in your life. I'm just getting old. Carbon paper existed when you had typewriters. Typewriters probably never ever saw a typewriter in your life either. Can we get this to work? Maybe not. Okay. Typewriter is a mechanical device that whacked a key or a piece of metal with the letter engraved in it onto a piece of paper. And you type away, and it would hit the paper with a ribbon between the paper and the key. It would whack that and it put the image on the paper. Used for 100 years or so before we discovered that you could do it better electronically. carbon paper was put between two sheets of paper, so as you're typing it, you can make two copies at once. I might point out, it's very hard to erase. Once you've typed something, you got to go back and erase both. That's what whiteout was invented for. It's a mess. I might point out that the QWERTY keyboard, QWERTY being QWERTY, the letters on the top of the keyboard, why such a really clumsy layout? Because it was invented to be clumsy. It was invented to be slow. If you type too fast, the fingers would get ahead of the typewriter keys and they get tangled up and get snarled. Been there, done that. So somebody invented the QWERTY keyboard to be inefficient. That is not very useful right now. It would be nice if we had a keyboard layout that was more efficient. There are other layouts that are much more efficient, but almost everybody in the world makes keyboards like this, so that's what you have. That's carbon paper, just getting distracted. Okay, so let's think about this blind signature. The idea is that somebody's going to sign a document or a file without being able to read the file. Okay, so typical characters, Alice wants Tish to blind something with the message. Tish's public keys are N and E, usual letters, and N and D are the private key. So she'll sign it the usual way. A message raise the D power mod and gives you the signed version. She wants to do this. Well, Alice wants this without Tish being able to read M. So here's how it's done. Alice gets a random number, some big random number that does not evenly divide into N, whose greatest common divisor of N, our N is 1. Okay. Then she multiplies M times R to the E, where E is Tish's E. That's the public key E that Tish has, mod N. So usually it's M to the E mod N. In this case, it's M times R to the E mod N, R being the big random number. Alice then sends B, this blind version, to Tish. Tish can't read it because it's got M to the E, doesn't know what the random number is. So then Tish signs B, creating X, which is the signed version, times B to the D mod N, where again, D is Trish's private key. And Alice can unblind it by using S to the X, that's the signed version, times R inverse mod N. And it ends up, now Alice has the signed version, which is M to the D mod N. How does this work? Real quickly, we'll go through this. This will not be on the test, but sometimes it's interesting to see how they did this. Pretty clever, I thought. Okay, the blind version is M times R, random number raised to the E mod N. The signed version is B raised to D. So that's signed version. You do this, then you give it to the person who's going to sign it, and then they sign it with the private key. Okay, so now we have it. We can unblind it by raising S to the X, which is the blind version, times the inverse of R mod N. Okay, substitute. We would have X is this, we substitute B mod N over here. So B to the D mod, it's all mod N times R. Substitute from 1 that B equals this, and that gives you this mess. So we have M times R to the E. Distribute the D's. You have M to the D times R to the ED times R. Well, remember, E and D are inverses. So R to the ED is just R. And then you notice you have R times R inverse. Well, that's just 1. And you end up with X to the MD mod N. Dave Schaum was pretty clever to figure that one out. Why would you want to do that? There are many times where an organization may want to sign something saying, yes, they've had this, but they didn't look at it. Think of a voting system, where the voting system has to verify that, yes, they received this ballot from this person, but they didn't look at it. Or a bank system may want to sign something saying, yes, we got this, but we don't know what it is. And here's our first clicker question for the day. Let's see if this works. That's interesting. Okay, and we'll try. Does anybody in class need a clicker? Right, has anybody need to replace their paper ones that might be wearing out? I bought some new plastic ones. Okay. Okay. Stand by while. There they are. Okay, everybody hold up your shiny new card in proper orientation, making sure your fingers are not covered. Hold up where? Proper letter up, okay. All right. Oh, well, C and B are pretty popular. Same thing online. There we are. Well, the proper answer is B. Bob cannot view it because it's signed by Alice. He doesn't have Alice's key, or it doesn't signed by Trish. He doesn't have Trish's private key, which or Alice's private key, so he cannot view that. Okay, enough of that stuff. Let's talk about digital money, which is the topic for today. First of all, real money. Real money is useful comparing against digital money. Real money is anonymous. You can go with a stack of $100 bills and give it to the guy, and there's no tracing. Nobody knows where that money comes from. Yes, they all have serial numbers, but as a general rule, people do not keep track of the serial numbers of their bills, small unmarked bills. Treasury Department works real hard to make it hard to difficult. Excuse me, makes it hard for you to copy money. They do not want you to counterfeit. There's all sorts of things. The $100 bill, this one doesn't show it. It's got the plastic strip through it. It's got micro printing, watermarks. It makes it really hard to copy. You just put it on a Xerox machine, isn't going to do it. Mind you, a lot of people try that, but it doesn't work real well. Certainly, if you take it into a store, they're not going to get away with that. Also, the paper is rather unique. Okay, and downside of real money that if you lose it, if it gets burned up, it's gone. That's it. You lost it. By the way, if you damage a bill of any size and you still have 60% of it left, the bank will give you the full value for it. So if you burn one side of it, the bank will give you a new bill for it. Okay, digital money wants to be kind of similar to that. Some of the goals, you should not be able to make up your own money. Again, counterfeiting just doesn't work. Once you get a digital dollar or some digital money, you should only be able to spend it once. If you try to do something fraudulent, should, in some sense, identify who's doing this, at least prevent you. Also, simple system failures should not lose your money. While, yes, if you lose a real dollar bill, you lose it, but really easier to hold on to than electronic things. If some sort of glitch happens, you shouldn't all lose all your money. And you want privacy. Talk about that. We have credit cards. Credit cards are out there. Credit cards have some sense of security. The bank has a central server. When you go and you put your card or tap your card or swipe your card or whatever you do with it, it sends a message to the server. The server looks at your card, makes sure that in fact it's authentic, debits the money from your account, credits the money to the bank's account, and sends back a message to the merchant that, yes, this is done. It's somewhat secure, although the bank knows how much money you have, how much money you spent at which merchant, when and where. So it's not very private. Okay, so I have a couple ideas for digital money. Let's try to go over this. This one, several of these use blind signatures. Okay, we have the First Digital Bank of Greensboro, and assume it has an RSA key. Alice is going to withdraw X dollars, whatever X is, from the bank, and so she tells the bank she wants that, and she sends, again, a big random number. And so she sends that back. The bank saves that big random number, and it sends back a message to Alice saying, okay, I've got that. I will encrypt that. Oh, by the way, Alice encrypts her, signs her request with Alice's private key. So when the bank gets it, it can check the key to make sure, yes, this really did come from Alice. The bank sends a response to Alice, signing it with the bank's private key. So Alice gets it, knows it came from the bank, and digitally signed note for however many dollars she wanted. She then gives that to Bob to buy something from Bob. So now Bob has it. It has the amount of money, that random number, and it's signed by First Digital Bank. Bob can check to make sure that it's signed correctly, so he knows it's legitimate. Bob then sends it back to the First Digital Bank of Greensboro. First Digital Bank verifies that, yes, that's their signature. They can look at the nonce and say, yes, this has not been spent before, and then we'll deposit X dollars into Bob's account. The bank will then send a deposit slip back to Bob saying, yes, got your request, we've done it. And Bob, having now verified that that was a message from the First National Bank, First Digital Bank, because it's signed by them, can give a receipt to Alice, and we're done. Alice has got the money. Okay, all the transactions were digitally signed, so nobody can deny they got them. Everybody's sure that it came from proper source. I didn't show any encryption. We could have encrypted all of them for confidentiality. Encrypt them with the receiver's public key. So Alice is sending a message to the bank, she would encrypt it with the bank's public key. The bank keep track of where Alice is spending the money. The bank knows that Alice got that much money, and it came back from Bob, because they know what account it came from. So the bank can also keep track of Bob's customers, so the bank knows where Alice is spending her money. So there are other ways you can do this. Anonymous Digital Cast. Dave Sham, yes, the blind signature fellow, has an idea. Each bank has a set of certificates, one for each denomination of digital money. There are other ways to do this. This is one that. Okay, so here we go. There are several parts of this. Alice wants to buy something from Bob for so many dollars. But this works well if you think of this as happening online. Bob's so Alice wants to buy something from Bob. Bob says, okay, sends a request about, I'm going to deposit X dollars in the future. And sends them a random number, sends it off to Bob's bank. Bob's bank says, that's fine, saves that random, and digitally signs it with Bob's bank. By the way, I don't show the nonce in this. Try to imagine the nonce is there. I realized this afternoon that I had forgotten the nonce after the first message, but didn't have the time to go back and update every picture to do that. Okay, so Bob now has it, and it's digitally signed by Bob's bank. Bob gives it to Alice, says, okay, my bank wants that much money. Alice can, of course, check the deposits, check it to make sure it's signed properly. Alice can then sign that deposit. She can blind sign that and send it off to Alice's bank. Alice's bank can check that it's signed properly, but doesn't know what. She withdraw X, she's telling the bank she's withdraw X dollars. They don't know from whom because they can't see this. Alice has got that signed, blind signed. So they send back a deposit slip. Alice then gives that to Bob. It's signed by Alice's bank. Bob knows that it's true. Bob then sends it to his bank. Bank can see that it is signed, sends back a deposit slip, and everything is fine. It's kind of complicated, but we're sending things back and forth. We blind signed it, so nobody knows. It's secure. Everything is encrypted. Everything is signed. The bank doesn't know where Alice is spending its money. The bank doesn't know who Bob's customers are because it was blind signed. So everything is secure. It's kind of complicated. You can look at all the details, but that's Sham's method for digital currency. There are, of course, other ways to do it. Quite a while ago, Dave Sham again came up with the blockchains. I've heard a lot about blockchains that are out there. Okay, blockchains are a method of they solve the Byzantine generals problem. What is the Byzantine generals problem? By the way, that's all blockchain does, is solve the Byzantine generals problem. Byzantine generals is a distributed consensus problem that a whole bunch of remote online entities can come to an agreement about some value. And so we have a bunch of, and you do this in the presence of faulty communications and possibly malicious participants. It all follows the idea of the Byzantine general, Goth war back in 535 AD. But basically, you've got multiple armies. The generals have multiple armies. If they all attack at the same time, then they are assured of winning. They will outnumber the enemy. But if they don't all attack at the same time, if numbers of them fail to attack, they'll be defeated because the enemy will overwhelm them. So they want to be able to send messages to the generals and come to an agreement that, yes, they'll attack at dawn, and make sure that even though some of their couriers, when they're sending couriers out to all the generals, some of the couriers may be captured and the messages will not get through, you still want to come to a consensus, even in the presence of faulty communications. That's the problem. And blockchains solve that problem. Bitcoin uses blockchains to come to a consensus whenever something is purchased or you buy or sell Bitcoins. It was invented back in 2009 by this unknown person or group. And it is now one of the largest, or I think the largest, digital currency in the world. Bitcoins are created by mining. We'll talk about that. And there are 83 million Bitcoin wallets out there. So I have a question. This is have you ever owned a Bitcoin? You ever bought a Bitcoin? So this is just, we'll find out. I've been teaching this class for a while. I taught it way back when they first invented Bitcoins and they were worth less than $1. I should have bought a few. Okay, let's just see your answers. Remember, this is anonymous. I don't know who you are. Scan it out those cards without keeping track. Maybe I'll know. Oh, okay. Let's see. There are 13 people who said yes and 15 people who said no. That's about half the people in class have owned a Bitcoin sometime. So they are kind of popular. We'll talk about Bitcoins. Sort of, there you go. Okay. Bitcoins have a blockchain, as you just discussed. Blockchain, as you add a new block to the blockchain, there is a hash that involves the previous block, this block, and you must perform a hashing such that you get a hash value where the upper bits are all 0. It's kind of like finding a certain value that you will come to an agreement with a SHA-256 hash. But we always said you can't go back with the SHA-250, SHA-1, or any one of these SHA-256 hashes. Given a hash value, you can't find a document that fits that. But that's exactly what they're trying to do. They're trying to go back. But they're not being exact, because exact is just too hard. They're just trying to be sort of exact. So find a hash that's less than a certain number of bits long, and that's short, and then they'll do it. So it's kind of going backwards. You don't have to find the exact number. You find a number that's good within, I don't know how many bits, but maybe a couple million numbers. Okay, so you've got all these hash data, all these data values down here, hash them, hash, and that goes into the block, the previous block hash, and keep going. So they're linked together, have timestamps, and they're hash previous ones. You have to be able to do the hash. That tree, by the way, looking at this tree, it's a Merkle hash tree. You've got all the data at the bottom. It's hashed, and then it's combined together, and there's a hash of that combination, another hash. So you got a binary tree, and it's hashing all the pieces. So if you make any change anywhere, it can be detected. Bitcoins, all this is done by Bitcoin mines. Originally, anyone could mine Bitcoins. Then, well, it's always been a race. When a new value is put on there, it's the miners are the people who go out and try to find the proper value, a hash that works. And it's a race. Who finds it first? The organization that finds it first gets the reward for mining. There are Bitcoin mines, rack after rack after rack of specially developed machines. They have custom chips that would do this. So they try to be as fast. Obviously, they spent a lot of money doing this. At one point, China used to mine most of the Bitcoins, but then China decided they didn't like this, and they banned cryptocurrency mining in their country, and so none of them are mined there. The United States does mine more than anybody else. I saw in the news the other day, there was a Bitcoin mine facility out in the middle of nowhere in the Midwest. And the people who lived around it were complaining because the air conditioning for the Bitcoins made so much noise that they were living in this very loud environment where previously they lived out in the middle of nowhere and nobody had any noise. So they were kind of upset about it. This is in Kazakhstan. Yes, Kazakhstan. It's a mid-Asian country, but there's a lot. In Russia, there's a lot. Why do they do this? Because they get paid to do it in Bitcoins. The reward for mining halves every 210,000 blocks that they do. It started at 50 Bitcoins and dropped to 25 now. Now it's only 3 1/8 Bitcoins for every mining adventure. And it should continue until there's 21 million Bitcoins in the world, which somebody estimates to be around 2140 or over 100 years from now. Note that while the value of mining a Bitcoin drops, the value of the Bitcoin varies widely over the years. So right now, it's worth about $197,500 to mine a Bitcoin. That's pretty good, if you can do it with your laptop. And who knows, you might get lucky. You might be the first one, but you're competing against organizations that have scads of Bitcoin servers that run very quickly. Interesting Bitcoin facts that I got out here. The first Bitcoin transaction was to buy a couple Papa John's pizzas. Somehow the fella convinced the delivery man to take 10,000 Bitcoins for the pizza. That, of course, was a $25 pizza, so you do the arithmetic, and that means Bitcoin's worth a quarter of a penny. Might point out that if the delivery man saved 10,000 Bitcoins, it'd be worth $632 million today. Oh, he did. Way back in February 2011, Bitcoin value increased to $1. And then it hit a maximum price of $75,000 in March of this year. So it's gotten kind of expensive. Okay, another question about Bitcoins. As you might guess, sometimes I'm really pressed to come up with answers. Oh, we have a tie. We're tied with B and C. There's slightly more folks online are big with B. No, the answer is C. C is the proper answer, that the miners get the new Bitcoins. Nobody said A. Okay, thank you. Couple of issues about Bitcoins. For many cryptocurrencies, it's difficult for the government to follow them. People tend to use Bitcoins for illegal transactions. If you want to buy drugs or a bunch of weapons, boxcar full of AK-47s, people tend to like to use Bitcoins, even though they are not private. We'll talk about that. And they want to have taxes. There are a lot of companies out there that tell you they'll help manage your cryptocurrency taxes. Uses a lot of electricity. We'll talk about that. There's now a limited number of miners. The whole idea is that there used to be the idea that we have lots and lots of people who work on this together and you come to a group consensus. Now the group has gotten to be quite small. And if they collaborate together, they could mess up the system. And price volatility, I'm going to talk about that. Interesting, this year or back in March, a FTX, which is a cryptocurrency created by Sam Bankman-Fried, went bankrupt because Mr. Bankman-Fried was taking the money and spending it as his own, frauding the people. At one point, he was the 41st richest man in the world because he was taking all this money that people invested, spending it himself. He's now doing 25 years in prison. So, as I said, the Bitcoin seems to be a popular thing for people trying to do illegal things. Colonial Pipeline Company here in Greensboro, which has underground pipes running all over the country, pumping oil and whatever else needs to be pumped around, were attacked with a ransomware. They paid for 63.7 Bitcoins to the company. The government got it back. The FBI, Department of Justice, got the money back, but the price of Bitcoins varies so much. And they were unlucky in that when they gave the Bitcoins to the ransomware, to the criminals, it cost one price. And then the value of the Bitcoins was significantly less when the FBI got it back. And so they lost a couple million. Okay, Bitcoins are not anonymous, in case you're thinking of selling AK-47s by the truckload. No, the blockchains are publicly visible. Government can track this, and the wallets all report what's going on. So they're not nearly as anonymous as people think they are. Interesting to look at the status of Bitcoins across the country. There are multiple countries that prohibit the use of Bitcoins, China being a big one, a couple other African countries, I think that's Afghanistan, Dominican Republic. Bitcoin is the public tender, the legal tender, the official government money for El Salvador. You can't see this, but El Salvador down there that's the only country. The United States allows it, some people. Russia is not quite sure. Okay. One of the concerns is the amount of electricity. Here is some charts. This is the kind of a maximum minimum amount that they might be using to create the Bitcoins. Here is the red line is kind of an estimate. You may note that at one point, the amount of energy spent to generate Bitcoins is more than Israel uses in a year, more than Argentina uses, more than Sweden uses in a year. It's a lot of electricity. And that, of course, has environmental impacts. You're out there creating lots of electricity for what? To mine Bitcoins. By the way, there are better ways to do that. there's lots of digital currency. The Bitcoin is not the only one. There are 20,000 different cryptocurrencies, most of which have come and gone pretty quickly. As of September 4th, this month, the total value of all the cryptocurrencies is $2.02 trillion, so Google tells me, with Bitcoin accounting for a little over half of all that. So they are the most popular. I think Ethereum is the next one. So here's a chart of the number of transactions per day. You can see Ethereum is pretty popular. There's a lot of Ethereum going there. Bitcoin's there. And who is that? Litecoin. I don't know Litecoin, but there are people on the bottom. As the Bitcoin blockchain has more and more added to it, it gets bigger and bigger. And you see it's just going up and up and up. Why are people using Bitcoins? Well, Bitcoin originally was thought to be a means of purchasing. It would be currency. You want to buy something with Bitcoins. Well, that rarely happens. People tend to use Bitcoins for investments. I think you saw in the beginning, Bruce Schneier, who's an expert in cryptography, thinks that Bitcoins are useless. Bloomberg investment company thinks they're useless. The volatility is amazing. They're 7 times more volatile than gold, 8 times more than standard. We'll take a look at some charts. Here is a chart of the Bitcoin price, for several years. And you can see it goes up and down quite a bit. This is, it's hard to see the scale, but that's in tens of thousands of dollars on the right side. So it's bouncing up and down. There's Ethereum, which scale is not nearly big. Ethereum bounces up. I've tried to adjust these charts so that the time frame, so like 2020 all lines up. Okay, there's Ethereum. It goes up about the same time as that. There's FTX. That was Bankman-Fried's. And it rises up, drops. There's the Standard & Poor's. Standard & Poor's is a index of 500 stocks in the New York Stock Exchange, and it's been going up, not steady, but not very volatile. There's the exchange between euros and US dollars. It's pretty stable. The line across here is equal, where 1 euro equals $1. And here's another chart where somebody's looked at the volatility, tried to measure it, and they find that Bitcoins are, in fact, quite a bit more volatile. Although there are other things out there, commodities, that would be people who buy wheat futures or gold futures. Well, gold varies quite a bit. Interesting, long-term government bonds wiggles a bit. Okay. So I also like William Shatner. I think you probably know who he is. Okay. Now would be a good time to look at the exam. Okay. All right. Okay. First exam, which you took last week. We have graded it. It took us a long time and a lot of effort to grade. It probably wasn't the best grade. Well, excuse me, wasn't the best exam I've ever written. I may have written worse, but I don't remember when. Okay, this is the grading scale for the course. As you can see, very generous, go all the way down to 87 for an A. Here's how the grades broke out. You can see there were a lot of A's, more A's than any other grade. There were other grades. There were some bad grades, particularly if you're a graduate student, that's really bad. A bunch of C's. Note that the pluses and minuses have smaller ranges in the grading scale than whole grades. Yeah, B's, 70, 72, what is that? It's this range of 5. This is a range of 2. A lot of C possibilities. Okay. All right, here are the results by the different groups. Sometimes I'm concerned whether the certificate students are doing well or the undergraduates. It's very hard to see, but the median line of the certificates, the median line of the master's students is almost the same. The undergraduates are slightly higher. Part of that might be that the undergraduates have different questions than some of the graduates. The blue boxes represent the 25 to 75% percentile of grades. the lines going up and down represent the range. Yes, there's some show off who got 100. Yes, question.
Blackboard, it says the number and then out of 124 points.
Yes, okay. Yes, there's a question about how many points. This is a 100-point exam. All the exams and assignments are all out of 100 points. It says 124 points because there were some questions which were only for graduate students, some questions that were only for the 422 students. So you didn't do all 124. Some people did. There were a couple of jokers out there who answered both of them and ended up with scores of over 100, which I had to go back and fix that. Also, I've learned if I leave the question alone, don't leave the answer to be 0, because some people just put 0 down to indicate they're not answering, and that got it perfectly correct. So I'll fix that next time. But I've gone back and checked that, spreadsheeting all over the place this morning. And so now, yes, a maximum score of 100, even though ignore Blackboard. By the way, Blackboard is also not very good at scoring your weighted percentage. We will talk about that in a minute. But if you remember from the exam, from syllabus, all the assignments together, throwing out the worst one, not the exams, the quizzes and homework assignments, all averaged out, count for 20% of your grade. There will be 3 exams, each counting for 20% of your grade, and then the final, which counts for 20% of your grade. So, okay. Question number 2 talked about destroying files. After significant discussion with the TAs, we decided that this question was confusing, and we threw it out. I just gave everybody 12 points for that question. It was a 12-point question. Everybody got 12 points. So anybody upset about that idea? If you want, I'll take your 12 points away. Okay. It does turn out it has something to do with a write-up. Question 1 discussed write-up, because I did that because ChatGPT is incorrect. So, all right, here is the question that killed many people. Let's talk about this. You've seen the question. I'm not going to read the whole thing to you, but let's go over how you break out into the. Okay, Bob is top secret. As it says, Bob has got top secret clearance. Bob does not have any groups. Somebody wondered about that, sent me an email. I explained it to them. Yes. Doesn't say it's above all the groups. Read the question. If you took the alternate exam, I threw that in. Some people had to take the exam late because they were someplace else at the exam. They had informed me ahead of time, or they were sick. And so these people took the alternate exam. The alternate exam, I threw in a sentence that said, Bob is every category, which changes the question a little bit. Anyway, but it doesn't say Bob is any category. If you didn't understand, ask me. Some people did. So Bob is no category. Yeah, no, by default, read the question. Okay, Alice and Darth are both secret. Alice is in the research department of accounting, and so she's got research and accounting as her categories. Darth is accounting and marketing. All right, good for the people. Now let's look at the documents. Okay, the documents belong to the group. So research is secret, it says it's secret, and it's in the research group. Accounting is in the accounting group. Marketing is in the marketing group. And employee contacts is unclassified and no group at all. Okay, everybody good with that? Good so far? Now, remember, in order to read or write, depends on the dominating relationship. So you have to dominate one. I tried to find a picture for this, but I couldn't find one I could show in public school. Okay, in order to dominate, the level has to be greater than the level of. So if A is a person, B is an object, the level of the person has to be greater than equal level object. And all of the categories of the object have to be a subset of the categories of the user. So in order to read something, the subject, the person, has to dominate the object, dominate the file to read it. To write it, the object must dominate person. Good with that? What does that mean? Let's talk about Alice trying to access accounting point doc. Here's Alice, the secret with research and accounting. Okay, accounting doc. she's got accounting in there, so she dominates. At the same level, she can dominate that, so she can read accounting. But the accounting doc does not dominate Alice, so she cannot write it. Let's think about this. Alice is in the categories both research and accounting. If she could write the accounting doc, then she could write information about research in the accounting point docx. That would release information. Later, Darth, who does not have any clearance for research, could read that accounting doc because he's not the accountant and could see information about research. The whole purpose of the Bell-LaPoudre model is a mandatory access control system to prevent information from leaking out. Information could leak out, so that's not permitted. Questions about this? Okay, only about 5% of the students got questions 8 and 9 correct. So that hurt a lot of people. That's 4 points each. So a lot of people lost 8 points, except for the person who got 100. And there were other high 90s. Questions about that? Yes. Now, will I ask more questions about this? Oh, yes. When the final comes around, beware. I will not ask questions about this in the next exam or the exam after that. The second exam will only ask about material since that we covered from first exam to the second. And the third one will be the second or third. So no, there will not be more Bell-LaPoudre model questions. But be aware, we talked about this. I think the problem is previously I just gave you the information you see at the top and asked you what. Right? This is kind of like a story problem. If you think of old math in elementary school, there were story problems. Yeah, you had to figure it out. Okay. And took a long time to grade because the TAs and I debated this. What are we going to do? Yes, we have a question. Right. That would also be a problem too. So she cannot, again, one of the questions was, what access does she have to research point docx? The answer to that is she can read it, but not write it. Because for the research one, she can read from these two groups, but she cannot write files. Now, the TAs and I have been talking about the Bell-LaPoudre model quite a bit. I'm trying to understand this. We know what it says in the book, but to tell you the honest truth, I'm not exactly sure what does it mean to write to an existing file in upper level with the same category. What does that mean? We're not talking about editing it, because in order to edit a file, you have to be able to read and write it. If you created a new file, if you went out there and created a new file, that's easy. It would have your category or higher category and all of the categories that you have. But I'm not sure. It's much easier actually to think about Bell-LaPoudre if you think about databases. Imagine databases where tables had categories and security levels, because you can read from a table if you run, and you could insert rows into a table without having to see the table. You could update rows in the table without having to see the table. So that situation works. But on regular files, like we think of as, editing the document, that does work as well. You had a question? Yes. Well, normally you should be able to read and write, but you have to remember the categories. We talked about Bell-LaPoudre model in 2 phases. The first phase, yes, it was just levels, and she could have both read and written to it. Then we added the much more complicated idea of dominating, where we had categories. And because Alice has categories that the documents don't have, she could not write to them, because she could then release information in another category. Do you have a question? Yes. Yes, the research document, she could write accounting information into the research document. And then people who could read the accounting document could see the research information. I did this one because then I can use Darth as the example because he can read accounting, but he can't read research. Okay, yeah, oh, another question. Yes, okay, the question. Okay, yes, we're talking about the strong star rule, which says you can write up, read down, read and write at the same level, but you have to, the star rule has to follow the dominating requirement. That works if you don't think about the categories. But when you add the categories, as we did, and this question does use categories, then you have to follow the categories. Do you see how we could release information about research to people who can't see it? In other words, Darth could see information about research because Alice might possibly write some research information into the accounting document. Darth could then read the accounting document and find research information that he's not allowed to have. And the whole purpose of Bell Poodle, of mandatory access control, is to keep information from leaking out. It's confidentiality. Now, oh, well, another question over here. That's correct. She cannot, Alice can neither write to research or accounting, but she can read both of them. Okay, there is a very interesting question. How could she possibly do her job? Yes, it becomes complicated. One of the reasons I didn't say Bob has all the categories, because then Bob can't write anything. Because unless the document that has all the categories. Okay. Well, we'll get to this. Let's move on to rings. Okay. Bell Poodle is a confidentiality, try to keep information. Ring integrity or the BIBA integrity model is related to trying to keep the information being corrupted. That is, people at the bottom may have information from multiple sources and it may not be correct. You want to make sure you always have correct. So the people at the top are said to have the most correct information. And it allows you to read up so you can read that correct information above and you can write the information down to tell the other people, but you can't write up because you might be writing corrupt information. The BIBA model says you can read up and you can't, but you can't read down. It's the opposite of the Bell Poodle model. All right, the ring integrity model, which is in the textbook, and I did not expect you for a minute to have read that. Nobody reads the textbook, I know. So it's out there, but the whole concept was to compare that against the policy that you should have known and see what difference does this make, which, by the way, was a question at the end of the chapter. I think at the end of the chapter. This question, real answer is no. The ring integrity model provides what we call indirect contamination. Somebody at a high level can read contaminated information from a lower level and then write it at a higher level that contaminates the higher level information. So you have to, if you want to keep things integrity, you have to use the BIBA, not the ring. Okay. Then there's the time-based one-time password question, the TOTP. You looked at the name, you immediately thought, oh, one time. Maybe those, oh, we have another question over here. Does that really relate to?
I basically put there, I only got partial, and I wasn't even getting
The TA is instructed very carefully that if they didn't give somebody all the points, they're supposed to put feedback and explain why. I realized late in the game, like this morning, that some of the TAs hadn't done that. I will flog them. But if at any time you think, yes, for any of the questions, if you think you were improperly graded, let me know. Although I will tell you for questions 8 and question 9, this is the answer. If you didn't get that, you didn't get it right. But at any point, any of the other questions, if you thought it was big, and it's very possible, there's 97 students in this class. There were 14 questions. Extremely high probability that we made a mistake. So if it was you that we gave the extra points to, please let us know so we can fix that. All right. Yeah, it could happen. Now, I apologize if it did. Okay. One-time passwords. All right. Once you've successfully authenticated, it says successfully authenticated there, then you're not going to use that password again because you've already authenticated. You're already signed in. So you probably don't want to use that again. If you disable it, then nobody else can sign in. Not invalidating it, ChatGPT and some other AI systems said, well, it makes it so much easier to try again. Well, you won't try again because you were successful the first time. So, yes, I like this question, of course, because ChatGPT didn't like it, didn't give a good answer. Which brings to mind, 9% of the people reported using an AI system to answer the questions. That's foolish. I told you before the exam that all the questions went through an AI system. And if it gave a good answer, then it was not in the exam. And little logic says, you know, if A then B, not B then A. Okay, so yes. How long did it take you? About 2.5 hours. Some people spent more time. Some people were fast. But 2.5 hours was the average. 13% of the people thought that there were some secret questions. Actually, I don't think it's too bad. 87% of the people said the exam is material they expected to be on the exam. That's what all exams should be. Remember the old quote that the course was complete. What wasn't covered in class was covered on the exam. So I tried to make sure that there are no surprises. Some people thought the ring question was a surprise. Sort of. I didn't expect you to know the ring policy. I was asking you to measure the policy that you had against something different. How does it relate? The difference between the graduate and the undergraduate version, the 620 and the 422 version, 422 was not given the P and Q values like the graduates were. They had to figure them out. How do you figure that out? Well, you could write a program to do it. It's not that hard to factor two small numbers, factor really large numbers. But some people, there's a question here. The graduates were, when you graduate, you were given a P and a Q value, and again, N, which is P times Q. The undergraduates were not given P and Q. They were just given N and E, and then they had to calculate what D was. Yes. Talk to me about that. We'll figure it out. Okay. If you're in 620, not so much whether you're undergraduate or graduate, if you're in 620 and not 422. If you're an undergraduate and Comp 620, then you had to do the 620. Yes, question.
I'll be able to find references, but
And you're in 620?
No, I'm under.
Okay, if you're an undergrad in 620, then you follow the 620 rules. Okay, you're in 422. Oh, 422 students were not given P and Q.
Oh,
Okay, yes, 422, no P and Q. If you were in 620, I gave you the P and Q values. So the 422 question was harder. Oh, I'm so cruel. It was harder, but then they had other questions that you didn't have. Yes, undergraduates didn't see the time-based one-time password question. Okay, again, if you thought I was evil and cruel, well, possibly, I work at it. But let me know if you think I misgraded your exam. I will try in the future to not come up with questions where only 5% of you can answer. I truly did not expect that. I expected to have like 60, 80% of the people answer it quickly. Yes, another question.
Oh, where's the time?
What?
Is it time? I have a question about the dominating.
The dominating question.
Since there's the categories, that means they have to also dominate? If it
Yes, you have to follow the dominating relationship, which involves categories being a subset of the other category. It's in the slides, it's in the textbook.
Right, would have to or would have to be higher.
In order for Alice to be able to write to that document would have to have all the categories that Alice has. That is correct. You have to have both. You have to have both categories she had. You could have additional categories than she had, but it had to have at least the categories that she had. It did not have both of them. Okay, if we beat that,
Those categories have to be at the same level.
yes, to right. Where's the mouse? Oh God. Oh. Oh, fine. Oh, there it is. Found it. Okay. We have 15 minutes left. We beat this to death. We have a few more slides here. How many is a few? It's about a dozen. Let's quickly go over the other material I have before everybody runs away. All right.
It seemed like the cost was ending.
You should see them online. They're running. I killed them. All right. Let me quickly go to Zoom, share my screen with the Zoom folks. All right, we're back. United States digital currency. The US does not have a digital currency, but they've been thinking about it. The White House had a technical report, a technical evaluation for US central bank digital currency. Central bank digital currencies, or CBDC. And many countries are considering them. Some countries have them. Many people are looking at them. The report did not make any recommendations that they should do this, but they looked at all the ideas. So how does that go? Okay, why do this? You facilitate efficient launch. You could probably get rid of the credit card companies, which do, as you all know, take a good chunk of money when you, merchants pay, like 3% whenever you use your credit card. That's a lot of money. The credit card companies are making huge quantities of money. If government took over the job now, that might make a huge mess of it. That's very possible. The government sometimes doesn't do things as efficiently as you might want, but it might reduce them, boost economic growth. And one of the things is moving money between international organizations might be a lot easier with a central bank, particularly if the government of the United States is going to move money to some other country's government. They do that occasionally. It might be a lot easier if they all used a digital currency. Of course, they're always concerned about the stability. We looked at the stability of Bitcoin is varies widely. No, if they had a digital currency, it would be tied to the paper dollar, and it would only vary as the paper dollar value varied. Okay, some secondary goals. Avoiding environmental concerns. In other words, you wouldn't use Bitcoin's logic that requires huge amounts of computing and lots of electricity. Want a good customer experience, of course, and facilitate transactions following all the rules we said for digital currencies. It has to be private, has to be, all the things we listed. There are lots of technical choices. and they aren't always binary. You can have a little bit of this and a little bit of that. This question got lost in my Zoom. I don't know why, but we'll forget it. Name it after. The answer is C. No, they have not made any decision about digital currency. Well, a couple of rules. People are going to do is all of these some intermediate involved. Intermediate might charge things and it would prove privacy, but it might be easier if you had some intermediate means. There's companies that do this, like the credit card companies would move from using dollars to US central bank digital company. Permissions. If there was public ledger, be less privacy, permissionless could be more sustainable. All is you're going to try to keep something like a Bitcoin blockchain. Privacy. Well, you're going to keep it identity private. If we do that, we might have keep it all private. Then it might be worse than Bitcoins for using it for illegitimate purposes. Of course, if you allow everybody to see you, it might be bad because people want to follow it. You might lose a lot of privacy. Cryptography. How are we going to do cryptography? The cryptography, PK, public key cryptography is PKC. And then there's zero knowledge proofs. Okay, zero knowledge proofs appear quite a bit in this sort of stuff. So let me briefly, one slide and zero knowledge proofs. The whole idea of a zero knowledge proof is you want to prove to somebody you know the answer without telling them what the answer is. There are multiple simple real life ways. One that I took from Wikipedia. Okay, imagine your friend is colorblind and cannot tell the difference between red and green balls. They all look gray to them. You can't tell the difference at all. And you're trying to tell them there is a difference. One's red, one's green. They're saying, no, it's not. How do you prove that there's a difference? The person who can't see it. Well, okay. The colorblind person shows you one of the balls. You look at it, you can see whether it is red or green. Then they put it behind their back and may or may not exchange the ball. They know what they did. They bring out the next ball and you can say, well, yes, that's red or it's green, whatever color that you can see. So if you do that, okay. Now, of course, they could guess. You just do red or green, you have a 50-50 chance of guessing correctly. So you do it again. And if you're correct again, now there was a 1 in 4 chance of getting it correct. And you do it n, it becomes 2 to the negative n possibility. So after you do this 20 times, there's a 1,000,000 to 1 chance that you're just guessing correctly. So your friend should be pretty well assured that you know the answer, but they don't know. They don't know which ball is red and which was green, but they do now know that there's a difference. That's a zero knowledge proof, where you prove that you know something without telling somebody what the answer is. Also, people want these hardware-based systems or software-based. They have little widgets that you can use to sell. They have them for Bitcoins that you can buy and sell Bitcoins. And digital signatures. Again, possibilities for digital signatures. Single signatures, more private. If you have to sign it and say intermediate signs it, then it could be more secure. Of course, people want it to be private, have less ledgers. Okay. Opposition. Well, the White House did this, but welcome to America. Yes, the White House did it, and they're Democrats in the White House, and so the Republicans are dead against it. They are concerned that having a central bank digital currency would reduce privacy. And if they don't do it well, that is probably a true concern. And so they have a bill out in Congress that says you can't make central bank digital currency. It's outlawing the idea, which of course hasn't happened, but they're outlawing in case somebody does do it. They have tabled it as of May of this year, and that's where it is. So it's not law. You can bet that if it gets to the White House, they're not going to approve it. So, all right. Another compromise might be to use central bank digital currency in the United States only for wholesale use. That is, between banks. Banks could transfer money to other banks using CBDC or between countries. Okay, as opposed to it. All right, remember that Wednesday, that would be 2 days from now at noon, you have to have completed the number-based quiz. The answers are on the website. If you want to look on the class website, there's the answers. So you might open up 2 windows, one with the answers, one with the questions, and do it as quick as you can. You have to be fast. You have to do it in 180 seconds or less if you want to get a score of 100. With a little bit of effort, you should be able to get a score of 100. If you didn't get 100 on this exam, you might want to pick up some points wherever you can. So go out and do it. Questions about the exam? Nope. Okay, go out there and
I have
do
a
it.
quick question.
Yes, a question.
Yes. What would you advise be the best way to study for quizzes and exams going forward? Just the slides or anything else you would advise? Any tools to go look at?
I would recommend looking at the slides and looking at the textbook. I mean, the textbook doesn't cover this, but this is okay. Go out there and try this just because I want people to know this sort of stuff. It's useful to you. We'll talk about it later. Okay. Remember, you got to do it fast. Okay, that's it. That's enough for today. See you on Wednesday.
I got a question right quick.
Oh, question.
Yes. When for the exam, if I have a question I need to email you about, would it be better if I emailed you on Blackboard or just directly emailed you?
Oh, please, if you're emailing me, don't use Blackboard. Just email me directly. Blackboard doesn't pop up and say, you've got a message. My email system dings and honks and shows me a new message. Blackboard hides it. I'm sorry, some people send me messages via Blackboard. I didn't see them for a long time. So please don't do that. I just don't see them right away.
Okay, no problem. Thank you very much.
Okay, I'm gonna press goodbye.